Good morning. Hope everybody had a good 4th of July. This mini video is going to talk about our first assignment in week 4, which is homework number 10. I'm going to, before I start the assignment, I'm going to just talk about some canceling rules. Let's say we had this problem here. If we had 2 plus 3 over 2. And let's say we have another problem that has this problem, 2 times 3 over 2. Okay, and let me give you a choice here. One of these is correct. Can I cancel these 2's? Or can I cancel these 2's? Only one of these is the correct way of canceling. Which 2's cancel? The 2's on the left or the 2's on the right? Well, we can figure this out actually by doing the math. If I cancel these 2's on the left, I would end up with 3. Is this problem equal to 3? Well, this is 2 plus 3, and 2 plus 3 is 5. Is 5 divided by 2 equal to 3? Absolutely not. This problem over here, we'd end up with 3 if we cancel. Is 2 times 3 divided by 2 equal to 3? Well, 2 times 3 is 6. And 6 divided by 2 is equal to 3. So this is not correct. And this is correct. What's the difference between the two problems? Well, the only difference between the two problems is there's a plus sign over here and there's a multiplication sign over here. As long as we have multiplication going on, we can cancel. If we don't have multiplication, we can't cancel. And that's the idea on homework 10. Homework 10 is going to talk about rational expressions and simplifying rational expressions by canceling. But before we cancel, we need to make sure it's a multiplication problem. So sometimes we're going to have to factor. So let's start the assignment here. And this is the first problem. It says simplify the expression if possible. Select cannot be simplified if applicable. Okay, so let's look at this first problem. Part 1. Is this a multiplication problem? Does it have multiplication? No, it doesn't. There's a minus up top and there's a plus. So we cannot do any canceling at all here. It'd be like canceling those 2's on that example on the left that I showed you. This 18 and this 14 are being subtracted or added to something else. So in this one here, we want to select cannot be simplified. However, in part 2, they give you the problem without the minus and the plus, and this is a multiplication problem. And this one here, we could go ahead and cancel. Now the 18 and the 14, they have common numbers that go into them, just kind of like if you simplify fractions. Number that goes into 18 and 14 is 2. So we would have a negative on top. 2 goes into 18 9 times. And 2 goes into 14 7 times. And the A and the B do not cancel. The only time you can cancel letters is if they're the same. And so we put in negative 9A over 7B here. Okay. I think when we click this box, it'll give you a box here, a box over a box. And so you're going to be using this a lot. Clicking that, and you put in negative 9A on the top, and then you put 7B on the bottom, just using your keyboard. Okay, it's called simplifying expressions. I'm going to go clear this and go to problem number 3. Problem number 3 gives you a expression, and it gives you 3 parts. It says factor the numerator and denominator. Do not simplify the common factors. That basically means go ahead and do the factoring, but don't do any of the canceling yet. So they want you to factor the top and factor the bottom. And again, the reason why we have to factor is because these are not multiplication problems. These are addition. So we need to use what we learned last week and factor the numerator and the denominator. So now both these start with x squared. So I know when I factor, I can factor, and I'll just put it here for a. I can factor on the top, it's going to factor something like that. And on the bottom, it's going to factor with a couple sets of binomials. So I'll just do the top first. We have an x squared, so we know it's x and x. This is a diamond problem. I put 48 on the top, and it says 14 on the bottom. So numbers that multiply to get 48 and add to get 14. We have to know our times tables a little bit. I know my times tables. I know that 8 times 6 is equal to 48, and I know that 8 plus 6 is equal to 14. So it's going to be plus 8 plus 6. On the bottom, the denominator, it's negative 32 on the top and 4 on the bottom. I always draw these little diamonds to kind of get my brain thinking about the numbers that multiply to get the last number and add to get the middle. 32 is 32 is 8 times 4, and so if I make the 4 negative and I make the 8 positive, I have negative 4 plus 8, so it's negative 4, so it's x minus 4, and then x plus 8. Okay, so what they want you to do for part 1 is just type this exactly in. So let me just do that so I can get to part 2. Okay, so x plus 8, so I'm going to use parentheses. X plus 8 and plus 6 up, and the bottom is x minus 4 and then x plus 8. Check answer. Okay. Part 2 asks you to determine the restrictions on x. Separate multiple answers with commas. All right. So these restrictions are we can never divide by 0 in math. Remember, we use that word undefined when we divide by 0, and so to find the restrictions, we simply look at the denominator, and we look at the denominator here, and we find out all the different x values that make the denominator equal to 0. It says separate multiple answers because sometimes there's 2 values that are going to make your denominator 0. Let's think about this one for a second. What value of x would make that 0? If I let x be 4, that's going to be 0, and 0 times anything over here. If I let x be 4, this is going to be 4 plus 8. That's going to be 12. But 12 times 0 is equal to 0. So we can't let x be 4. X cannot equal 4. So it says x cannot equal here. This is not equal to. So x can't equal 4. And then what value of x makes this 0? Negative 8. So both those values here, we click this box and we just put 4, comma, negative 8. answer. Okay, and now the last part, this is where they want you to actually simplify the expression. So if when you do the factoring, you're probably going to see something that cancels. In this case, the x plus 8 is multiplied by the x plus 6, and down here the x minus 4 is multiplied by the x plus 8. So these x plus 8s are going to cancel, and you're left with this x plus 6 over x minus 4. Now, do not get overly excited about canceling. Okay, some people get a little bit excited and they start canceling everything that they see that's the same. This x plus 8 is exactly the same as this x plus 8, so they cancel. This x is the same as this x, but it's being attached. It's attached to the 6. So these x's cannot be canceled because this is a addition problem, not a multiplication problem. This is a subtraction problem, not a multiplication problem. The only time we could cancel is if we have a multiplication problem. So this is actually our simplified answer. X plus 6 is on top. I think we need to leave them in print. I'm going to try not putting parentheses in. I'm just going to put x plus 6. Don't believe we need parentheses. I think we can just leave them out here. And then x minus 4. Let me check my answer here. Yeah, so we don't need to put the parentheses. If you did put the parentheses in, I don't think it'll mark you wrong. You can leave them in if you want, but usually if you just have a binomial by itself, you don't need parentheses. Okay, let me clear my screen here and go on to number 5. All right, number 5 are just two monomials. There's no addition or subtraction, so that means you're factoring. You don't need to factor. You can just do your canceling. I like to kind of think this in 3 different parts. You have the numbers, right, and then you have the letters. Actually, so we have 4 different parts. We have the numbers in front, and we have the letters A, B, and C. So let's look at the numbers first. We have the numbers 24 and 6. 24 and 6, we could cancel 24 and 6. Well, 6 goes into 24, so 6 goes into 24. Let me draw the bar here. So 6 goes into 24 4 times. So that 6 is going to go away, and that 24 is going to become a 4. And now let's look at the A's. We have 1 A on top, and we have 7 A's on the bottom. So one of these A's, this A right here, is going to cancel with one of the A's on the bottom. So we're going to be left with 6 A's on the bottom. That's because there's more A's on the bottom than on top. Next, move on to the B's. We have 3 B's on top, and we have 1 B on the bottom. So this 1 B on the bottom is going to cancel with one of the B's on top. So we're going to be left with B squared in the numerator. And then we have C squared on top, and then we have C to the 0. We haven't seen an exponent 0. I don't believe we've seen an exponent 0. We've seen exponents like 2 to the 3rd, right? We've seen exponents like 2 to the 2nd, right? We've seen exponents like 2 to the 1st, but we haven't really seen an exponent 0. So let's talk about that for a second. 2 to the 3rd, that's 8. 2 times 2 times 2. 2 to the 2nd, that's 4. Just 2 times 2. 2 to the 1st, well, that's just 2. Right? 2 to the 0. Well, I'll put a little question mark here. 2 to the 0. Let's see what's happening here. I'm giving you guys the exponents. Now you go 3, 2, 1, 0. Look what happens here. What's happening to this? What's the pattern? How do you go from 8 to 4 to 2? What's going on? Yeah, you're kind of taking half of it, right? 8 divided by 2 is 4. 4 divided by 2 is 2. 2 divided by 2, well, what's 2 divided by 2? 2 divided by 2 is equal to 1. Anything raised to a 0 power is not 0. Anything raised to a 0 power is equal to 1. Any number raised to the 0 power is equal to 1. So really, all this is right here, this c to the 0 just means that we have a 1 there. This is right here, this is equal to 1. Not 1, not c to the first, but that's just equal to 1. It basically means there's no c's. There's no c's there. C to the 0 means there's nothing there except for the number 1. So that means we have c squared left on top. So we just type that in. I'm not going to type it in. I'm going to save a little time and let you type that in. You might not have exactly the same problem on 5, but it'll be something similar. Let's go to number 11. Okay, so number 11 does have a minus or plus. Anytime you see minus and pluses, think you're going to have to factor. Okay, don't go to the canceling before you do the factoring. I'll say that one more time. Don't look at this problem and start canceling out things that are the same unless it's factored. So remember, our first step in factoring is to pull out the greatest common factor. So the greatest common factor on the top is a 2. So when we take out a 2, we have a z minus 2 left over. And the greatest common factor on the bottom is also a 2. And we have a z squared minus 4 left over. Now, these 2's can be canceled. This z cannot be canceled with this z because this is a minus sign right here. So these are not multiplication problems anymore. This is a multiplication problem, so we can cancel those 2. But we can't cancel anything over here unless we can factor further. And I think we can factor further. We can't factor the top. The top is z minus 2. But the bottom, z squared minus 4, is I'm going to draw the diamond. So remember the last number is on top of the diamond. Now, if we don't see a middle number, it's 0. So this is a special type of factoring here. It's a binomial, and we have a -4 on the top and a 0 on the bottom. So 2 numbers that multiply to get -4 that add to get 0. You got it. 2 and -2. 2 and -2 multiply to get -4, and they add to get 0. So this is going to be z plus 2 and z minus 2. Well, see this z minus 2 on top? That cancels with the z minus 2 on the bottom. However, if everything cancels on the top, you can't just leave it blank. You have to put a 1 on the top. So it's going to be 1 over z plus 2. 1 over z plus 2 would be your final answer here. Okay, so there was two factoring steps to do that problem. Always try to factor out the greatest common factor first before you factor a second time. It's very easy to maybe only do the factoring once and write this as your answer. Okay, it'll probably say something like your answer is correct but needs to be factored further. That's why you have to go one more step. Okay, so this is your answer over here. And I'm going over this a lot in the the lecture later this morning. So make sure you view that video, those of you that are are busy. Okay, go over 12. All right, so this one here is going to be a little bit different factoring. It's trinomials, but there's a number in front. So let's just look at the top first. You're going to have to factor the top and the bottom. You're going to have to factor both the top and the bottom. So let's see. The top, anytime I have a number in front, I look to see if it's common. Is it common? No, it's not common because 11, 2 doesn't go into 11. So remember, I multiply these two together, and I get negative 12. I'm going to factor this by grouping here. Multiplies to get negative 12, adds to get 11. That's negative 1 and positive 12. Negative 1 and positive 12 multiply to get negative 12. They add to get positive 11. So I write, let's see, I write 2y squared minus 1y plus 12y minus 6. Okay, so then this is the top. Now I'm going to factor by grouping. So it looks like there's a y common in the first. So there's a y common. And so it's 2y minus 1. So hopefully this has a 2y minus 1 in it as well. And I believe it does. You take out a 6. And it's 2y minus 1. Remember, in order for factoring by grouping to work, you have to have the same factor in each. So the top of this rational expression is 2y minus 1 times y plus 6. That's what the top factors. So the bottom is probably going to be something that we can cancel. But let's see. So the bottom here, let me change colors to blue here. So the bottom, I notice it starts with a negative. Anytime it starts with a negative, I'm going to factor out a negative first. Okay. I talked about that last week. Anytime it starts with a negative, factor out the negative. If it doesn't start with a negative, you don't have to factor out the negative. Actually, it's common that you don't factor out the negative if it doesn't start with a negative. So when I factor out the negative, that's going to be 2y squared. And that's going to change that to a positive 13y. And that's going to change that to a negative 7. So now I'm going to go ahead and factor. I'm going to go 2 times negative 7. So I'm going to do it the same way as I did the top. 2 times negative 7 is negative 14. The middle number is 13. That's going to be a negative 1 and a positive 14. So that negative stays out in front. And I'm going to leave it in parentheses here. 2y squared minus y plus 13y, no, plus 14y. This has got to be 14 because I have negative 1 and positive 14. So this has got to be 14y minus 7. Okay, so I'm going to factor out a y. So it's going to be y, let's see, y times, it's 2y minus 1 plus, and then there's a 7 common to 14 and 7. So I factor out a 7 and I get 2y minus 1 again. So now I can just, remember I just leave this negative that came out, and then I can write, let's see, I can write 2y minus 1, and I can write y plus 7. So that's what's going to go up here. Negative on the outside, and 2y minus 1, and then y plus 7. So now this 2y minus 1 here cancels with this 2y minus 1 here. However, that negative stays there. That negative stays there. So when we write our answer, we want to use the, let's see, y plus 6. And I don't really need to leave it in parentheses. On the bottom, though, I'm going to write the negative out in front and then start my parentheses and put the y plus 7. So now I have that negative there, which came out at the beginning, and I can check the answer. Okay. Lots of factoring. Okay, lots of factoring, lots of canceling, and that's basically how you're going to do it. A little shorter homework set. Instead of having 30 problems, you only have 20. And I will be going over more of this during the lecture today. All right. I have a good week, and be prepared for another discussion question in week 4's module. And the midterms coming up this week. I think I'll have that available by Thursday, and it'll go over all the topics that we've talked about. Bye for now.